Welcome friends, welcome to another video lecture of Biovision Academy. And friends, today we are going to discuss about Jablonski diagram. Okay friends, Jablonski diagram is a diagrammatic representation of processes like fluorescence and phosphorescence. Okay, so I would like to suggest you to watch my previous videos which is based on the process of fluorescence and phosphorescence. Okay, those videos will help you to understand about the fluorescence and phosphorescence. Okay friends, but for now we are going to discuss about Jablonski diagram. Okay friends, so let's start Jablonski diagram. Student, you know that every molecule is present in their ground state, and after absorbing an energy, molecule leave their ground state and reaches to an excited state. Okay, so the step in which molecule absorb an energy to their ground state and leave their ground state and reaches to an excited state is termed as absorption. Okay, is termed as absorption. Okay, now here ultraviolet rays or visible rays are used as a source of energy. Okay, now student, after reaching to an excited state, molecule start coming back to their ground state, because an excited state is also an unstable state. Okay, so to attain this stability again, molecule leave their excited state and start coming back to their ground state. Okay, when molecule coming back from an excited state to their ground state, it release its energy in the form of radiation or heat. Okay, so this process is termed as relaxation. Okay, students, relaxation are of two types. One is radiative relaxation and another one is non-radiative relaxation. Okay, radiative relaxation is that kind of process in which when molecule is coming back from an excited state to their ground state, it emits its energy in the form of radiation, or in other words you can say that it emits its energy in the form of light or photon. Okay, and the example of radiative relaxation are fluorescence and phosphorescence. Okay, now when the molecule is coming back from an excited state to their ground state by releasing heat, then such kind of relaxation is termed as non-radiative relaxation. Okay friends, so in other words you can say that Jablonski diagram is a diagrammatic representation of the processes like absorption and relaxation. Okay friends, now student, to understand about the Jablonski diagram, you should know about the singlet state of an electron and triplet state of an electron. Okay, so before discussion of Jablonski diagram, I would like to tell you about what is singlet state and what is triplet state of an electron. Okay, students, you know that molecules generally contain paired electron. Okay, suppose that it is a molecule. Okay, it is a molecule and this molecule contain paired electron. Okay, this molecule contain two electrons which are paired. Okay, now students, you know that electrons has the property to rotate around its own axis. Okay, so suppose that this electron is rotating in a clockwise direction and this electron is rotating in an anti-clockwise direction. Okay friends, so that state of an electron in which both the electrons have opposite spin, then such condition is known as singlet state, known as singlet state. It's termed as singlet state. Okay, friend. Now, you know that when a charged body rotate, it behave like a magnet and generate magnetic field. So, electrons are also negatively charged and it is also rotating around its own axis. So, electrons are also behave like magnet and generate magnetic field. Okay. So, when an electron is rotating in a clockwise direction, then its magnetic field is represented by using an arrow pointing up. Okay. And when an electron is rotating in an anti-clockwise direction, then its magnetic field is represented by using an arrow pointing down. Okay. So you can say that in a singlet state, the magnetic field generated by the spinning of an electrons are in anti-parallel direction with each other. Okay. In anti-parallel direction. Okay. Now, student, suppose that the electrons which are present in singlet state are in ground state. Okay, are in ground state. Now, what happens if we provide an energy to the molecules in which electrons are present in singlet state? Okay, suppose that we are providing an energy to the molecule. Okay, suppose that it is an energy in the form of UV radiation or visible light. So suppose that UV or visible light is used as a source of energy. Okay. Now, student, after absorbing an energy, one of electrons of singlet state leave their ground state and reaches to an excited state. Okay, one of electron of the paired electron, not both, only one electron absorb an energy and leave their ground state and reaches to an excited state. Okay, so one electron is still present in their ground state, which have a clockwise rotation, and another electron reaches to an excited state which have an anti-clockwise rotation. Okay, which have an anti-clockwise rotation. Okay, okay. So and this is excited singlet state. Excited singlet state. Got it, friends? So, in excited singlet state, one electron is present in ground state and another electron is present in their excited state. Okay, student, in their ground state and in their excited state, the spin of an electron does not change. It means in the ground state, the electron is rotating in an anti-clockwise direction, and after reaching to an anti-clockwise direction, after reaching to an excited state, the electron is still rotating in an anti-clockwise direction. So in the ground state and in excited state, the spin of an electron does not change. It remains same in their ground state and to an excited state. Okay, friends. Now, in ground state, the electrons are paired, but in excited state, the electrons are now unpaired. Okay, but the spin of an electron does not change. It remains same in their ground state and in excited state. Okay, friends. Now, students, suppose that after reaching to an excited state, the spin of an electron is changed. Okay, the spin of an electron is just changed. Okay, this electron is rotating in an anti-clockwise direction. So after change of spin, now this electron is start rotating in a clockwise direction. Okay, and this electron is still present in the ground state. So we are going to write this here. Okay, so student, you can easily observe that when the spin of an electron changed in their excited state, then the electrons of an excited state and the electrons of the ground state have the same spin. Okay, both electrons are rotating in a clockwise direction. Okay, so that condition of an electron in which both the electrons have same spin, then this condition of an electron is termed as triplet state. It's termed as triplet state, and this is excited state, so we termed it as excited triplet state. Okay, now, so what is the main difference between singlet state and triplet state? Okay, singlet state is that condition of an electrons in which both the electrons have opposite spin. Okay, whereas triplet state is that condition of an electron in which both the electrons have same spin. Okay, now triplet state is formed by the electrons of an excited state, excited singlet state. Okay, now, so students, this is all about the singlet state and triplet state. Okay, now we are going to discuss about the main part of Jablonski diagram. Okay friends, student, consider that a molecule contains paired electrons and the paired electrons are present in singlet state. It means both the electrons have opposite spin. Okay, suppose that these are two electrons. Okay, and these two electrons have opposite spin. Okay, now, and this is the ground state of singlet state. Singlet ground state. Okay, now student, the molecules have paired electrons which are present in singlet state, so we are going to represent their ground state as S0. S represent the singlet state. Okay, now suppose that it is the ground state of an electrons which are present in their singlet state. So S0. Okay. Now student, in next step we are going to provide an energy. Okay, suppose that it is an energy. Now as I told you, after absorbing an energy, one of electrons leave their ground state and reaches to an excited state. Okay, students, there are so many excited states present for the molecules. Okay, suppose that it is first excited state, it is second excited state, and it is third excited state. Okay friends, and these excited states are represented as S1, as represent the singlet state. So S1 means first singlet excited state. Okay, S2 represent second singlet excited state, and S3 represent third singlet excited state. Okay, now after absorbing an energy, one of electron leave their ground state and reaches to an excited state. Okay, student, an electron reach to any one of excited state. It may reach to S1 excited state, it may reach to S2 excited state, and it may reach to S3 excited state. Okay, suppose that an electron may reach to S1 excited state, or it may reach to S2 excited state, or it may reach to S3 excited state. Okay, it may reach to S3 excited state. Got it? Now student, after reaching to an excited state, molecules, or you can say an electron, start coming back to their ground state, because an excited state is an unstable state, and there is a tendency of every molecule that it always want to maintain their stable state. So to regain their stability, again molecule start coming back from an excited state to their ground state. Okay students, when molecules start coming back from their excited state to their ground state, it does not come back directly from their excited state to their ground state in a single jump. It means it does not come back directly from S3 to S0 state. Okay, from S3 to S0, it is not possible. Electrons come back to their ground state in step by step. It means first it comes from S3 to S2, and then from S2 to S1, and then from S1 to the ground state. It means it comes step by step. Okay, suppose that this electron which was reached in S3 excited state, it start coming back to their ground state. So it comes like this. First it comes from S3 to S2, from S3 to S2, then it comes from S2 to S1. Okay, and now it start coming back from S1 to S0. Okay, it means electron from an excited state first comes to the next lower excited state, and then from next lower excited state to the next lower excited state. So it comes step by step to the lower excited state. Okay, now student, the process in which molecules, or you can say an electron, comes directly from S3 to S2 and from S2 to S1, then this process is termed as IC. Okay, IC is a process in which an electron is come back from one excited state to the next lower excited state, and this process is termed as IC. Okay, or you can say that an electron is start coming back from one excited singlet state to the next lower excited singlet state of. Okay, in other words, you can say that electrons are coming back within the same multiplicity. Okay, within the same multiplicity. Okay, this is the singlet state. So transition of electrons takes place from one singlet state to the next lower singlet state. Okay, now student, when the molecule is coming back from one excited state to the next lower excited state, then it releases its energy in the form of heat. Then it releases its energy in the form of heat. Okay, then it's released its energy in the form of heat. Got it? Student, IC stand for, the full form of IC is internal conversion. Internal conversion. Okay, the full form of IC is internal conversion. Okay, now student, when an electron is coming back from lowest possible excited state to their ground state, okay, the lowest possible excited state is S1 and the ground state is S0. So in that condition, when electron is coming back from the lowest possible excited state to the ground state, then it shows the process of fluorescence. Then it shows the process of fluorescence. Okay, then it shows the process of fluorescence. Okay friends, so for fluorescence, the electron must be come back from the lowest possible excited state to the ground state. Okay, now student, suppose that electron is coming back from S2 to S1 and from S1 to S0. Okay, suppose that this electron which is reaches to S2 excited state is now start coming back to their ground state. So first it come back from S2 to S1 and then from S1 to S0. Okay, now when an electron is coming back from S2 to S1, then it releases its energy in the form of heat. Okay, in the form of heat. Got it? And when electron is coming back from S1 to S0, it means from lowest possible excited state to the ground state, then it shows the process of fluorescence. Okay, now student, suppose that an electron which is reaches to S1 excited state is now start coming back to S0 energy, S0 ground state. So there are two possibilities. It may release its energy in the form of heat, or it may show the process of fluorescence. Okay, now suppose that it may release its energy in the form of heat, or it may show the process of fluorescence. Okay, now students, suppose that the energy gap between S0 and S1 is very low. Okay, so in that condition the electron release its energy in the form of heat. But if an energy gap between the ground state and S1 excited state is very high, in that condition the molecule release its energy in the form of radiation, that is fluorescence. Okay, so there are two conditions for fluorescence. One, an electron must be coming back from lowest possible excited state to the ground state, and the energy gap between the lowest possible excited state and the ground state must be high. Okay, if any one of the condition is not fulfilled, then the process of fluorescence does not take place. Okay friends, now student, as I told you, when an electron of singlet state leave their ground state and reaches to an excited state, then the spin of an electron does not change. Okay, and when an electron is coming back from an excited state to their ground state, then the spin of electron is also does not change. It means it remains same throughout the process. Suppose that electron is reaching to an excited state, so the spin of electron does not change. Suppose that this electron leaves their ground state and reaches to an excited state. Okay, suppose that here this is the third. Okay friends, now students, when the molecule, or you can say when an electron is coming back from one excited state to the next lower excited state by releasing heat, okay, then this process is termed as non-radiative transition, or you can say non-radiative relaxation. Non-radiative relaxation. Okay, non-radiative relaxation, in which when an electron is coming back from one excited state to the next lower excited state, it releases its energy in the form of heat. Okay friends, now when the molecule is coming back from lowest possible excited state to their ground state, then it releases its energy in the form of fluorescence. So fluorescence is a radiative process. Is a radiative process, or you can say radiative relaxation. Got it? Friends, when an electron is coming back from an excited state to their ground state, okay, then spin of an electron remains same, but it means it does not change. So if it is rotating in an anti-clockwise direction in an excited state, then it is still rotating in an anti-clockwise direction when it is coming back from an excited state to their ground state. Okay, so spin of an electron does not change. Okay friends, so students, the time period of IC, you can say internal conversion, is about 10 to the power minus 12 to 10 to the power minus 14 second. Okay, and student, the time of absorption of an energy when the molecule is present in their ground state is about 10 to the power minus 15 second. Okay friends, and the time of fluorescence is about 10 to the power minus 4 to 10 to the power minus 8 second. Got it? Now students, let's talk about some another important points in Jablonski diagram. Okay, fluorescence, student, as I told you in our previous video lectures, triplet state is a lower energy state and it is more stable than singlet state. Okay, because singlet state is a high energy state and it is less stable. Okay, and this stability and energy level is defined by using the electron spin multiplicity and by using Hund's rule. Okay, so if we draw the triplet state, then we should draw the triplet state slightly below from the singlet state. Suppose that we are drawing an excited triplet state as compared to the S3 excited singlet state, then we should draw the triplet state slightly below from the S3 excited singlet state, and we written it as a T3. Okay, slightly below. And same, the second excited state is slightly below, is written slightly below from the S2 excited singlet state. Okay, and this is the, now got it? So this is the T3 excited triplet state, this is the T2 excited triplet state, and this is the T1 excited triplet state. Okay, now student, when an electron change their spin, then it forms the electrons of the triplet state, and triplet state is that condition of an electron in which both the electrons have same spin. Okay, and in triplet state, one electron is present in their ground state and one electron is present in their excited state, and electrons of the triplet state is formed by the electrons of the excited singlet state. Okay, suppose that the electrons of the S3 excited singlet state is now change their spin. Suppose that it changed their spin. Okay, when this electron is rotating in an anti-clockwise direction, so it start rotating in a clockwise direction. Suppose that it is now rotating in a clockwise direction. Okay, got it. So when the spin of an electron changed in their excited singlet state, and after change of spin the electron is jumped to the excited triplet state. Okay, now this electron is jumped to the excited triplet state, that is the T3. Okay, now got it, friends? So student, the process in which an excited electrons of the singlet state change their spin and jump to the triplet state, or you can say triplet excited state, then this process is termed as ISC. Okay, ISC, and the full form of ISC is inter-system crossing. Okay, inter-system crossing. I will jot down here ISC, and ISC stand for inter-system crossing. Inter-system crossing. Okay, friends. Now, so you can say that ISC is a process in which an electrons of singlet excited state change their spin and jump to the excited triplet state. Okay, now suppose that electrons of singlet excited state S2 change their spin and jump to the excited T2 triplet state. So this is also an ISC process. Maybe electrons of S1 excited singlet state change their spin and jump to the excited triplet state. Okay, so this all process is termed as ISC. ISC. Okay, now got it, friends? Now, student, as like in excited singlet state, the electrons of triplet state is now start coming back from an excited triplet state to the next lower excited triplet state, just like in excited singlet state process. Okay, so electrons are now start coming back from T3 to T2 and from T2 to T1 and from T1 to their ground state. Okay, got it? Student, as I told you, when an electron jump from one excited state to the next lower excited state, then this process is termed as IC, internal conversion. See, IC. Okay, so this is the jumping of an electron from T3 excited state to the next lower excited state, that is T2, is also termed as IC. Is also termed as IC, and IC stand for internal conversion. Okay, now student, there is a transition of an electron takes place between the same multiplicity. It means between the triplet state of an electron. Okay, now here you can easily observe that the lowest possible excited state is T1, and from that T1 state an electron is coming back to their ground state. Okay, so when an electron is coming back from their lowest possible excited triplet state to the ground state, then it shows the process of phosphorescence. Then it shows the process of phosphorescence. Then show the process of phosphorescence. And student, the time of phosphorescence is about 10 to the power minus 3 to 10 to the power minus 5 second. Okay, friends? Students, the time period of ISC is just like same to an ISC process. It means the time period of ISC is also about 10 to the power minus 12 to 10 to the power minus 14 second. Okay, friends? Now, student, in this triplet state, you can observe that an electron is coming back from T1 excited state, which is the lowest possible excited state, to the ground state, and the ground state is singlet state. So, when a molecule is relaxed from the different spin multiplicity state from T1 to the S0 ground state, it means from triplet state to the singlet state. Okay, then spin of an electron is changed, just like in this. Suppose that this is the excited singlet state, and when an electron is jumped from excited singlet state to the excited triplet state, then spin of an electron is changed. Okay, so here you can easily observe that this is the T1 excited triplet state, and electron is jumping back from T1 excited triplet state to the ground state. So the spin of an electron is changed. Now the electron which is rotating in a clockwise direction in their excited triplet state, so while coming back from T1 excited triplet state to the ground state, the spin of an electron is changed, and now it start rotating in a anti-clockwise direction. Okay, it now start rotating in an anti-clockwise direction. So you can easily observe that when an electron is come back to the ground state, then the singlet state is recovered. you can easily observe that one molecule is rotating in an anti-clockwise direction and another electron is rotating in a clockwise direction. So they have opposite spin. It means the singlet state is recovered. Okay friends, now student, so you can say that a phosphorescence is an ISC process. Phosphorescence is an ISC process, inter-system crossing process, whereas the fluorescence is an IC process. Fluorescence is an IC process. Okay friends, now student, when an electron is jumped between the excited state of the same multiplicity, it means from one singlet state to the next singlet state, then this type of transition is termed as allowed transition. So this process is termed as allowed transition. Allowed transition. And when an electron jump back between the two states of the different electron spin multiplicity, it means T1 to S0. Okay, the state of an electron is changed from T1 to S0. So such kind of relaxation, or you can say such kind of transition, is termed as non-allowed transition, or you can say forbidden transition. Okay, forbidden. Forbidden transition. Okay friends, got it? So students, let's write down the steps of IC, internal conversion, and steps of ISC, inter-system crossing. Okay, now IC, where the steps of IC takes place. Student, you can observe IC takes place between S3 to S2, or from S2 to S1, and from S1 to S0. Okay, and from T3 to T2, and from T2 to T1. So these are the steps in which internal conversion takes place. Now let's talk about the ISC. Student, ISC takes place between S3 to T3, and from S2 to T2, and from T1 to S0, and also from S1 to T1. So these are the steps in which the inter-system crossing takes place. Okay friends, now so fluorescence is an internal conversion process, whereas the phosphorescence is an inter-system crossing process. Okay friends, so students, this is all about fluorescence, phosphorescence, singlet state, triplet state, and Jablonski diagram. Okay friends, I have completed these videos in 3 parts. One part deals with the fluorescence and phosphorescence, another part deals with the difference between the fluorescence and phosphorescence, and about the singlet state and triplet state, and the last part of this topic covers the Jablonski diagram, which is a diagrammatic representation of fluorescence and phosphorescence. Okay friend, so I hope this video will help you to understand about the fluorescence and phosphorescence. Okay friends, so if you like this video, then please share this video with your friends, and please do subscribe our channel. And friends, please don't forget to press the bell icon, so next time when we upload a new video, you will get the notification from YouTube. Okay friends, thank you for your patience hearing. Have a nice day.